Problem Solved is supported by ACAM, a property management company serving the New York metro area and South Florida since 1983. Focusing exclusively on third-party property management, ACAM delivers a wide range of services, including capital project management, compliance, energy management, staff hospitality training, and industry-leading technology. To learn how ACAM can service your building, visit acam.com today.
Welcome to Problem Solved, Habitat's ongoing conversation about challenges facing co-op and condo boards in New York and how their professionals help them solve those problems. I'm Bill Morris, and with me today is Doug Lister, principal at Douglas J. Lister Architect. Leaks are, as we all know, a major problem in co-op and condo buildings throughout New York City. You've had a couple of interesting experiences lately. Let's start with the first one, a masonry building that had a serious leaking problem, and you took a sort of a two-fisted approach. Tell us about that building, Doug.
The first building had serious leaks after several nor'easters. This building had a long history of leaks since it had been converted into a condominium in the 1980s. We started by inspecting apartments where we had complaints, and we found really moist, wet plaster conditions inside the apartments. We found it throughout the building, even on low floors of the 17-story building. And in my experience, typically on lower floors, there really isn't a lot of damage. That's because the upper floors receive the brunt of wind-driven rains, although during heavy winds, all floors will get some damage.
Now, even the lower floors were experiencing leaks, so this was a universal problem in the building.
It was. We estimated that we had water damage from about 50% of the exterior wall of the building, and that's a very high percentage. Typically, we're talking about pre-war buildings here. A building with 100 apartments might have 5 or 10 apartments with leaks at any one time. That's a very low percentage of the wall area, maybe just a few percent. This is a really unusual situation. I'm going to back up a little bit and explain that the pre-war brick masonry buildings depend on the brick and the mortar that the brick is laid in to provide the waterproofing for the walls. A 16-inch thick wall will not get much water through it, but as the walls get thinner, which happened just before World War II, they're more and more likely to have leaks. But they still depended on the mortar for waterproofing. So we tested the mortar on this building, and we found out it was a mix that did not have much of the binders that we normally use in mortar. The binders are lime and cement. So it was a very inexpensive building built during the Depression, and the contractor had cut corners by using more sand and less cement and lime.
And this allowed moisture to penetrate that mortar in between the layers of masonry and get into the interior of the building
very easily. We believe that the building had always had leaks, even right after it was first built. It was an expensive solution, and that was to remove the outer layer of brick. We installed a waterproof membrane system behind a new layer of brick, and then we installed that new layer of brick on top. And we did that all over the building. In the industry, that's called reskinning. And like I said, it was a very expensive solution. It was about $50,000 per apartment. There were about 80 apartments in the building. It was about $4 million. So that's a very big number.
Let's go to case study B. Now, that was a different situation, a 100-unit building. What happened there?
Right. The second building, again, had leaks after wind-driven rains. And we, again, surveyed the apartments where we had complaints and found that about a third of the apartments had leaks. We estimated that we were getting water damage from about 10% of the exterior walls and in much more scattered areas than that first example. To have done the first solution to reskinning just wasn't warranted, and it would have been very expensive. So we did an unconventional approach. We did the waterproofing from the interior rather than the exterior. We went into people's apartments where they had leaks. We removed the plaster from their walls where we had damage. We put in a waterproof barrier on the exposed inside brick layer of the outside wall. That barrier was a cement-based layer basically stucco, and then we put back a moisture-resistant wallboard. It was a very intrusive system, but it stopped the chronic leaks from occurring. It's been in place for several years, and it's held up very, very well through wind-driven rains.
And this was
And
about a third of the apartments in the building. I assume people had to vacate while you did the work.
Well, they tended to move into other rooms of their apartments. The contractors built temporary barriers in their apartments while the work was underway.
So they were able to remain in the apartments. What was the cost roughly?
This was not an inexpensive solution. It came out to be about $10,000 per apartment. I estimate that was from 1/5 to 1/3 as much as a conventional targeted exterior repair project would have been.
I wonder if there's a lesson in these two case studies, Doug. It seems like leak problems are unique. As an architect, what do you tell your boards when they have a problem like this?
I recommend that if they have leaks or they're going to be doing an exterior repair project, they should survey the apartments, because a lot of shareholders and condo unit owners may not notice when they have water damage. If we do an exterior repair project and then after the project is done, a year later, 2 years later, somebody says, well, I have damage, then it's really too late to go back and do a repair from the exterior. Both of these buildings also have something else in common. About 8 to 10 years before they had done these projects, they had done previous projects of $2 to $4 million, and these projects were not totally successful. The boards had wasted money.
This time they did it right, and you haven't had any problems.
We surveyed and we did it right. Basically, buildings do exterior repair projects for 3 reasons: to fix potentially unsafe conditions, a local 11 or a FISP type of repair, improve the appearance of their building, and to stop leaks from the exterior. You can usually tell visually that you've solved the first 2 problems, but you cannot tell visually whether you've stopped a leak. And it's difficult to test to see that we've repaired a leak that only occurs during wind-driven rains. We can water test the exterior walls of buildings. We can spray water at them, but it's difficult to do a wind-driven test, which is really what you need to find out if you've actually fixed the leak.
Doug, thank you for these informative stories. Every leak story is a different story, right?
It is. Every building is different. That's definitely true.